Hey Fixers, and welcome to today's video session where I will show you how to use lambda functions and Boolean indexing to filter arrays. So this is part of my Python one-liners video series, and I will give away basically all the content of my new book, Python one-liners, for free in the video format. It can be either for readers of the book, or if you cannot afford the book, you can simply watch the tutorial. So I will give all the videos, so like all 60 sections I have in the book. I will create a video for it. I already have 20 videos, so you can check out the playlists that are associated to this video, and yeah, and you can get the content there. And so in this video, this video is motivated by the fact that real world data is noisy. So as a data scientist, so you get paid to get rid of the noise, to make the data accessible, because I mean, there's data everywhere. Yeah, so it's like this is the fundamental challenge of understanding data and of extracting meaning from the data to see the data that is everywhere and only get the parts that have meaning for a given situation, okay, that provide meaning. So filtering data is therefore vital for real-world data science tasks. And in this section you will learn how to create a minimal filter function in a single line of code with NumPy. So you can also use filtering for Python, and I have already created many tutorials. So if you would if you want to filter in Python, then you would use list comprehension or the built-in filter function. But in NumPy, it's actually easier, it's more concise, and in many cases, it's so if you have already imported the NumPy library, which you do with the following statement: import NumPy as NP, then you should use NumPy for filtering. Okay, so let's have a look at real-world data of the problem we want to solve. So as you know, each section in the book is first explains some basics, some background information. Then it gives a problem you want to solve, and then you solve the problem in this section with a one-liner solution. So this is like the challenge of the book. Okay, so in this book we have a list of lists consisting of 6 rows. So each row is a list by itself. Each row has 2 columns. The first column is a string value, and now this is the particular challenge of this puzzle. And the second one is a numerical value. And this means, as a NumPy array is homogeneous, it has only one data type. The common data type in this. So what is a common thing? So like the minimum. That applies to the minimum data type that applies to all data types in this array, and this is basically object. Yeah, so it's like so you have floats, you have strings, they have nothing in common, so it creates a NumPy array of type object basically, and therefore you cannot do some numerical computations on data type or object, yeah, because the strings, I mean, what does it mean? NumPy is for numerical computation, so if you create a NumPy array like this, then you can do something. Let's run this in a shell. Okay, now we have created the array books. Now we can check the type of books. Okay, this does not work. I think I already had this book dot ND type. Was it ND type? No, book dot books dot and type. No, maybe it was type books. Yeah, okay, so it was like this. So you type so I just used the wrong variable name, because the variable name is books. Okay, so you see it's it's a NumPy array, and yeah, of type object. So you can probably simply print books, and it gives you the data type, which is kind of this strange thing. So it's not a float or anything. Yeah, and good. So our challenge here is, so we consider the following problem. We want to create a filter function that takes a list of books X and a minimum rating Y, and returns a list of potential bestsellers that have higher than minimum rating, so where the Y value is larger than our minimum value. Okay, so we want to create this function. So therefore, if you want, we want to create a function predict bestseller, and it takes books, it takes this type of array, it gives us a minimum rating like 3.9, and then it returns all books that satisfy this rating. So here you have like the books, and you have the average rating of the book. And this is your function. This is what you want to accomplish. So you need to create a function in a single line of code. This is a challenge. So let's start right away. You create a variable name called predict best sellers, and now we use a lambda expression, of course, to create a function dynamically. So the lambda keyword, this is one thing I wanted to show you. So it takes 2 arguments here, separated with this comma value. After the lambda keyword is an anonymous function. So this whole thing, this whole expression creates a function with 2 arguments, x, y. So it takes 2 arguments and it creates a return value. And the return value, of course, can be anything, any expression based on your arguments. So now x is our books argument. Yeah, you see x. So the first value, we pass books into the argument list, and we pass the rating y, which is a float value. Okay, and now we need to get all. So basically we return a NumPy array, and we use Boolean indexing to access some values from this NumPy array. And yeah, so this is like our structure. Okay, so we access parts of our NumPy array x by using this square bracket notation. Now we have to put in the right thing here. So what do we want to access? We want to get the names of all bestsellers. Okay, so we want to get some names, and therefore we start with so we use slicing, which you have already learned in the previous videos of this one-liner session. So we use slicing, so we access all rows and the second column with index 1. Okay, the second column is index 1, the first column has index 0. So it's comma separated. Before the comma we have the axis 0 values, so which values we want to take from axis 0. In our case, axis 0 are the rows. And so we want to take all rows indicated with this colon notation. So from default start to default end, which means that we take all rows. So we have basically an array of a column vector, if you want. We take all rows, but we take only the second column with index 1. Okay, so this is like our basic thing. So we take all rows, but only the second column, which are these float values. And now based on those, we want to decide. So we want to decide whether to add this index or not. Okay, so we take all of those, and we check, are they larger than y? So we get as an output. So if we take this thing, yeah, we isolate the thing. So because I want to show you what happens here. So let's run this. Now it will throw an error, but I will just show you what happens if we paste this thing here. Okay, so we get all rows. We get the column vector of all the float values of all the ratings, and now we check whether they are larger than y. Now say y is 3.9. Now x is not defined. Okay, so we need to use books basically, yeah, because I mean this works only within the lambda expression. Books. Now what is the reason here? It's not okay. It works only in an argument list. Okay, I should have foreseen this. Okay, so it works only in the arguments list, so I can just no, this was not a problem. It should also work here, but I need to. So I simplified thing to explain it. So you should also use the S-type float. This is a problem I've already indicated previously, that the data type of the whole NumPy array is now object. Yeah, so and it doesn't and it's not of type float. So therefore you first need to convert it. Okay, and now you see the return value. So if I get rid of my face now, the return value here is a NumPy array of Boolean values. Okay, so like you have the first one is true, 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 false, 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 true. So what does it mean? It means that for your first book, here you see the books and their ratings. The first one is true because the rating is larger than 3.9. Second one is also true because it is larger than 3.9. Third one also. Fourth one false. No, it's not larger. So Winnie Pooh is not larger than 3.9. So therefore the return value is false. The fifth one, Clown of God, is rating 2.2. So it is also false. And then we have a true value for the Coffee Break Python book. Okay, so you see this returns an array. This expression here, if you convert it to a float value, this expression returns, so I will mark it, this gives us a Boolean value where the ith element will be true if and only if the associated y value of this book, of the ith book in your books array, has a rating larger than 3.9 or y in general. So y is the value you pass here. Okay, so this one gives you like this NumPy array with truth values, and now you can use this truth value in Boolean indexing to access only the elements, only a specific element, to decide for each element in your array. And an element now is a whole axis if you want. So this is the first element, this is the second element, this is the third element. If you don't use this comma notation here in the indexing scheme, but you only use like, so for example, let's replace this with 0, then this would return the first element here. Okay, and if you replace it with 1, then it would return the second row basically, yeah. And if you replace it with this thing, then now you have, for each row you have defined whether to access it or not. Okay, and so basically we want to only access the rows where the rating is larger than 3.9. So this basically solves our problem already, and it should return the correct result. So let's refresh our shell. Okay, now you see all the books. So we have returned all books that have rating larger than 3.9. So what happens if we like want to have only the books that have rating larger than 4.9? Then you see there's only one left, Lord of the Rings. Okay, so so that's it. That solves the problem. Pro NumPy coders will do this very quickly. They will understand very quickly what happens here. I think this is a nice trick to use this Boolean indexing scheme to get the indices of some elements that you want to access. But of course, it's difficult to grasp if you just watch a video, so you need to try these things out. So I would recommend that you go now into your Python shell, try a bit, play a bit around with this example, maybe create your own examples. Maybe you can use numerical types first, so you don't need to convert it. Then it's easier to understand because it's not as big of a one-liner. But actually, NumPy allows you to do a lot in a single line of code, and therefore I added it, of course, to this book, to the Python one-liners book. So check out the book and see you in the next video. Bye.